Here are a few questions from the paper Heat and Thermodynamics. Now we have to discuss them one by one. First question is define heat capacity. Heat capacity H equal to mc theta. M is the mass of the substance, C is the specific capacity, theta is the rise in temperature. The quantity of heat energy required to raise the temperature of whole mass of the substance to 1 degree Celsius is called heat capacity. From this, if you find the value of C equal to H by m theta, which is called specific heat. The quantity of heat energy required to raise the temperature of unit mass of the substance through 1 degree is called specific heat. Here, whole mass of the substance, entire mass of the substance through 1 degree is heat capacity. The unit of specific heat is joule per kilogram Kelvin. What is meant by Cp? The quantity of heat energy required to raise the temperature of unit mass of the gas through 1 degree at constant pressure is called Cp. If you measure the specific capacity at constant volume, that is Cv. So liquids and solids are having only one specific capacity value, but in the case of gas it has two values, one is Cp and another one is Cv. Cp is always greater than Cv. Why? You know the first law of thermodynamics, delta Q equal to du plus del W. This is du plus PdV. Pressure into change in volume is our work done. In the case of Cv, the value of dV equal to 0. Volume is a constant, therefore change in volume is equal to 0. So this quantity is 0. Then del Q equal to du. The given energy is totally used to increase the internal energy, that is temperature of the system. Whereas in the case of Cp, part of the energy is used to increase the temperature of the system and the remaining energy is used to carry out some work. So we need more energy to increase the temperature of the system in the case of Cp. Therefore Cp is always greater than Cv. Write down Mayer's relation. Cp minus Cv equal to R is the Mayer's relation. Here R is the universal gas constant. Next question is state Boyle's law. At constant temperature, volume of the gas is inversely proportional to pressure. So V equal to constant divided by pressure. Therefore PV equal to constant. State Charles' law. The volume of the given mass of the gas at constant pressure is directly proportional to its absolute temperature. V is proportional to T. Then V by T is a constant. What's an ideal gas? A gas that obeys Boyle's law and Charles' law without limitations is called perfect gas. In the case of a perfect gas, we are neglecting the intermolecular attraction. At the same time, the size of the molecule is negligible. What do you mean by real gas? The gaseous state of any substance has its molecules of finite though tiny size. The intermolecular forces of attraction are also present though negligible under normal conditions. These two become effective under high pressure and low temperature. At high pressure and low temperature, a gas is acted as a real gas. Suppose at low temperature, at high temperature and low pressure, we can expect a gas to act as an ideal gas. See here, state the conditions at which a real gas approaches an ideal gas. Real gases approximate ideal gases under low pressure and high temperatures. Whereas in the case of high pressure and low temperature, it's a real gas. Under low pressure and high temperatures, ideal gas. Write down the gas equation. PV equal to RT is gas equation. What is mean free path? The average distance travelled by a molecule between two successive collisions is known as mean free path. Suppose S is the total path covered by a molecule among a number of collisions, then mean free path lambda equal to S by N. This is the formula for mean free path. Lambda equal to 1 divided by pi d square N. Give the value of mean free path in terms of pressure and temperature. The pressure of a gas is given by P equal to nkt. From this, N equal to P by kT. Instead of N, if you put this value, we can get lambda equal to kT divided by pi d square into P. Therefore, lambda is directly proportional to temperature. If the temperature is more, mean free path is also more. Lambda is inversely proportional to pressure. If pressure increases, lambda decreases. Define mean square velocity. The mean square velocity is equal to the mean of the squares of velocities of the various molecules. Say C1 be the velocity of the first molecule, C2 be the velocity of the second molecule, C3 is the velocity of the third molecule, Cn is the velocity of the nth molecule. Take the squares and sum whole divided by n, that is our C square. If you take the root for this, you can get a root mean square velocity, C equal to root of this quantity. See this. Define root mean square velocity. The root mean square velocity of the molecule is the square root of the mean of the squares of the velocities of the various molecules. What are transport phenomena? Transport phenomena are those that can be explained using the movement of gaseous molecules. Viscosity, thermal conductivity and diffusion are the examples. Momentum is transported in viscosity. Thermal conductivity explains the transport of energy. Mass transport is confirmed by diffusion. What is meant by diffusion? The transformation of gaseous molecules from the higher concentration region to lower concentration region is called diffusion. The concentrations of the various layers of gas may differ. In such a case, gas molecules will move from higher concentration region to lower concentration region to reach a steady state, thereby transforming mass from higher concentration region to lower concentration regions. This is referred to as diffusion. What do you mean by degrees of freedom? The number of independent ways in which a molecule may make its movement is called degrees of freedom. State the law of equilibration of energy. The total energy of the molecule is divided equally to each degrees of freedom. Then the energy associated with each degrees of freedom is of kT. The total energy of any dynamical system in thermal equilibrium is divided equally among all degrees of freedom. And the energy associated with each degrees of freedom is 1 by 2 kT. Here K is a Boltzmann constant and T is the absolute temperature. What are the various modes of heat energy transport? Conduction, convection and radiation are different modes of transport. Define heat conductance. Heat energy can be transmitted from one place to another place without the actual movement of the heated particles is conductance. Heat energy can be transmitted from one place to another place with the actual movement of the heated particles is called convection. Without the help of any medium, heat energy can be transmitted from one place to another place is called radiation. Heating a metal bar is example for conduction. Water heating is example for convection. Then Energy coming out of a hot body is example for radiation. What is meant by coefficient of thermal conductivity? We know that Q is equal to K into A theta 1 minus theta 2 into T by X, the coefficient of thermal conductivity. The coefficient of thermal conductivity is defined as the amount of heat flowing in 1 second across the opposite face of a conductor maintained at a temperature difference of 1 degree Celsius. Here, if A equal to 1 unit, theta 1 minus theta 2, temperature difference is 1 unit, then time is 1 unit, and X is also 1 unit. Q equal to K. What is least disk method? Least disk method determines the thermal conductivity of bad conductors like cardboard, mica, ebonite, and glass. What is a perfect black body? A perfect black body absorbs all the heat radiations that fall on it. When such a body is placed inside an isothermal enclosure, it will emit the total radiations until it reaches equilibrium with the enclosure. These radiations are independent of the nature of the substance. Such heat radiations in a uniform temperature enclosure are known as black body radiation. What are the properties of a perfect black body? The black body absorbs heat radiations of all possible wavelengths and also emits the radiation of all wavelengths. Define emissive power. It is the ratio of the amount of heat radiation emitted by the unit area of the surface in 1 second to the amount of heat radiated by a perfect black body per unit area in 1 second under identical conditions. What is meant by absorptive power? It's the ratio of the amount of heat absorbed by the surface in a given time to the amount of heat incident on the surface at the same time. State Kirchhoff's law of radiation. The ratio of the emission to the absorptive power of radiations for a particular wavelength at a particular temperature is constant for all substances and is equal to the emissive power of a perfect black body at that temperature. State Stephen's law. The rate of emission of radiation by unit area of a perfect black body is directly proportional to fourth power of its absolute temperature. R is proportional to T power 4, then R equal to sigma into T power 4. Sigma is our Stephen's constant. State Newton's law of cooling. According to Newton's law of cooling, the rate of heat loss in a body is directly proportional to the temperature difference between the body and its surroundings. This law is only valid for small temperature difference. See, dH by dt is proportional to theta minus theta naught. To remove the proportionality sign, we are introducing a constant K. State Wien's displacement law. While talking about the black body radiation, in the black body spectrum, the energy corresponding to maximum is represented by a curve. If you are studying wavelength versus energy, we may observe the wavelength corresponding to maximum energy is represented by the letter lambda m. The wavelength corresponding to the maximum energy is inversely proportional to its absolute temperature. Suppose the temperature is increased, then the value of lambda m is also varied. So lambda m into T is a constant. As temperature increases, the wavelength corresponding to maximum energy is decreasing, so that the lambda maximum is shifted to smaller wavelength region on increasing the temperature. Read out this statement. This law explains the shift of wavelength corresponding to the maximum energy towards the shorter wavelength as temperature increases. It is suitable only for shorter wavelengths and fails to explain the distribution for longer wavelengths. States Rayleigh-Jeans law. Rayleigh and Jeans deduce the energy distribution law, which is d equal to 8 pi kt d lambda divided by lambda power 4, where d is the energy contained in the wavelength range lambda and lambda plus d lambda, T the absolute temperature of the radiation, and K is the Boltzmann constant. This law fails to explain the energy distribution at the lower wavelength region. This is very important. Next, state Planck's law. According to Planck's law, energy is emitted in the form of packets or quanta called photons. Each photon has an energy h nu. Here h is Planck's constant and nu is the frequency of radiation. What is Joule-Kelvin effect? When a gas is allowed to pass through the porous plug at a temperature lower than the temperature of inversion, cooling occurs. This is referred to as the Joule-Kelvin effect. The temperature at which the cooling effect becomes zero is called temperature of inversion. What is liquefaction? Liquefaction is the process of converting a gas into a liquid. A gas can be converted into a liquid if it is sufficiently cooled and simultaneously subjected to high pressure. What are helium 1 and 2? Liquid helium above 2.19 Kelvin is known as helium 1 and below 2.19 Kelvin is called helium 2. Helium 2 has abnormal properties. What is lambda point? In the temperature versus specific heat graph, see, this is temperature versus specific heat graph. This is C, this is T. The specific heat of helium 2 increases as the temperature increases. At 2.19 Kelvin, in the temperature versus specific graph, the specific heat of helium 2 increases as the temperature increases. At 2.19 Kelvin, the specific heat rises abruptly and decreases as temperature increases. See here, at 2.19 Kelvin, the specific heat increases abruptly and then decreases as the temperature increases. The graph looks like a Greek letter lambda, therefore the temperature 2.19 K is called lambda point. This is lambda in Greek, lambda, capital lambda. How does the viscosity of liquid helium change? The viscosity of liquid helium 1 decreases with a decrease in temperature, whereas the viscosity of helium 2 is 0. What is rolling film? The viscosity of helium 2 is 0. Helium 2 forms a thin film on all solid surface and is called rolling film. It can flow very rapidly even through a highly narrow capillary tube. What are superconductors? The electrical resistance of certain materials suddenly drops to 0 if the temperature of that material is less than a certain temperature called critical temperature. The phenomenon of occurrence of zero electrical resistance is called superconductivity. The materials having such a peculiar property are called superconductors. If T lesser than T0, Tc, then R equal to 0, electrical resistance equal to 0. How are superconductors classified? Superconductors are classified as type 1 and type 2. Type 1 superconductors are called soft superconductors and type 2 superconductors are called hot superconductors. What do you mean by critical temperature? The temperature at which superconducting transition takes place is called the critical temperature. Say this is a critical temperature. If T lesser than Tc, material is a superconductor. Temperature of the specimen is greater than Tc, it is a normal conductor. The superconducting nature of material depends upon temperature. If the material's temperature is less than a critical value, it behaves like a superconducting, and above that point it is a normal conductor. The temperature at which such a transition takes place is called critical temperature. What is Meissner effect? Meissner studied the effect of magnetic field on superconductors. Below the critical temperature and the magnetic field lines are expelled from the specimen's interior. The phenomenon of expulsion of magnetic flux from the interior of the superconducting specimen is called Meissner effect. See, this is a superconducting material. If the temperature is greater than Tc and the magnetic field is greater than the critical field, magnetic field lines are passing through the specimen. So it is acted as a normal conductor. Suppose the temperature is lesser than Tc and the magnetic field value is lesser than the critical field, the value of B inside the specimen is 0. The magnetic field lines are expelled from the interior of the specimen. This is called Meissner effect. The value of B inside the specimen is 0. Therefore, we know that B equal to mu naught into H plus M is mu naught into H into 1 plus M by H. M by H is our magnetic susceptibility. Intensity of magnetization to the field applied is called magnetic susceptibility. Therefore, mu naught into H into 1 plus chi equal to B. According to Meissner, B equal to 0. Therefore, mu naught into H into 1 plus chi equal to 0. But mu naught into H not equal to 0. Therefore, the quantity 1 plus chi equal to 0, then chi equal to minus 1. This concludes that all the superconductors are perfectly diamagnetic in nature because of negative susceptibility. What are the applications of superconductors? Superconductors are used to fabricate electromagnets. They are used in practical accelerators and power transmission. Superconductors are used in memory storage devices. State zeroth law of thermodynamics. If two bodies A and B are in thermal equilibrium with the third body C separately, then they are in equilibrium with each other. The consequence of zeroth law is temperature. Temperature is the thermal condition of a substance and measures its relative hotness. State the first law of thermodynamics. The quantity of heat energy given to the system is equal to the change in internal energy and the amount of external work done. Here, heat and work done are path functions, whereas the internal energy is the state function. Therefore, we have given inexact differentiation for heat and work done. But for the internal energy, we have given exact differentiation. State the second law of thermodynamics. First one is Clausius statement, second one is Kelvin statement. According to Clausius, it is impossible for a self-acting machine, unaided by any external agency, to transfer heat from a cold body to a hot body. According to Kelvin, it is impossible to get continuous supply of heat energy by cooling it to a temperature lower than that of its environment. State the third law of thermodynamics. At absolute zero, entropy approaches 0. Define a thermodynamical system. A system is a definite quantity of matter, maybe a solid, liquid or gas, bounded by some closed surface. Systems are divided into three types. They are open, closed and isolated. What's a open system? Matter and energy are exchanged with the environment is an open system. Typical example is air compressor. What is a closed system? In the case of closed system, only the energy is exchanged with the surroundings. Typical example is a cylinder with a movable piston containing a gas. When a gas is heated, heat energy is entering into the cylinder. This is a exchange of energy only. What's an isolated system? An isolated system is one that does not exchange energy or matter with its surroundings. A thermally isolated cylinder containing a gas fitted with a piston is an example of an isolated system. What are thermodynamical variables? Pressure, volume, temperature, internal energy and entropy are called thermodynamical variables. Define the term internal energy. The sum of the kinetic and potential energies of all the gas molecules taken together is known as the internal energy of the gas and is denoted by the letter U. The heat content of the system at constant volume is also called as internal energy. What is isothermal process? An isothermal process occurs when the pressure and volume of a substance change but the temperature remains constant. The equation is PV equal to constant. What's an adiabatic process? When a change in pressure and volume of a substance takes place, but no heat is allowed to enter or leave it, the change is said to be adiabatic. The required equation is PV power gamma is a constant, where gamma is our Cp by Cv. Specific capacity at constant pressure divided by specific capacity at constant volume. Recognize the difference between isothermal and adiabatic processes. Isothermal process is a slow process. In an isothermal process, the temperature remains constant. The adiabatic is a quick process. Furthermore, in an adiabatic process, temperature varies but entropy remains constant. Compare the slope value of isothermal and adiabatic processes. The slope of an adiabatic is gamma times the slope of an isothermal process, whereas gamma equal to Cp divided by Cv. Formulate an expression for the work done in an isothermal process. Work done is equal to integral PdV. We know that PV equal to RT. Therefore, P equal to RT by V. Then take this RT outside, integral dV by V. If you differentiate this, you may get the numerator. So, log of the denominator is the formula. So, log V. W equal to RT into log V. Then we have to apply the limit V1 and V2. This is RT into log V2 minus log V1, which is equal to RT into log V2 by V1. Formulate any expression for work done in an adiabatic process. Using the formula of PV power gamma equal to constant, we arrived at this. Here PV power gamma equal to RT, then P equal to RT divided by V power gamma. Then work done is equal to integral PdV, which is equal to RT into integral dV by V power gamma, which is equal to V power minus gamma into dV inside the integral. If you integrate this, we may get V power minus gamma plus 1 divided by minus gamma plus 1. Here we have to apply the limit, lower limit V1, upper limit V2. This is changed as V power 1 minus gamma. So V2 power 1 minus gamma minus of V1 power 1 minus gamma. This minus gamma plus 1 is changed as 1 minus gamma. What is a reversible process? The system in a reversible process can be reversed so that the working substance experiences the same conditions as in the direct process. The conditions for a reversible process include slowness and the absence of frictional force. Example, ice to water, electrolysis, etc. What is an irreversible process? An irreversible process is one that cannot be retraced in the opposite direction. Example, work done against friction, Joule-Kelvin effect, rusting of iron. What is an indicator diagram? The indicator diagram is a curve that represents the state of a system using points on a PV plane. What is a cyclic process? A cyclic process is a thermodynamic process that returns a system to its initial state after a series of changes. Identify that thermodynamic variables that do not change during a cyclic process: pressure, volume, temperature, internal energy, and entropy. What is Carnot's engine? A heat engine is a physical configuration that converts heat energy into mechanical work. In practice, a heat engine's efficiency ranges between 5 and 25%. Carnot created an ideal engine with the highest efficiency. It has a source, a zinc, a working substance, and non-conducting stand. Give the formula for the efficiency of Carnot's engine. Eta equal to 1 minus T2 by T1. Here eta is the efficiency, T1 is the temperature of the source, T2 is the temperature of the zinc. Is it possible to achieve 100% efficiency in a Carnot's engine? Not possible. The efficiency of Carnot engine is eta equal to 1 minus T2 by T1. If T2 is 0, we can get T2 by T1 equal to 0, so eta equal to 100%. Here T2 is the temperature of the zinc. T2 is having some minimum value, not equal to 0. Therefore, we won't get 100% efficiency. State Carnot's theorem. According to Carnot's theorem, all reversible engines operating between the same two temperature limits have the same efficiency. No heat engines can be more efficient than Carnot's reversible engine working between the same limits of temperatures. We know that efficiency eta equal to 1 minus T2 by T1. The efficiency is depending upon the temperature of the source and the temperature of the zinc, which is independent of the nature of the working substance. Suppose if you allow few reversible engines working between these two temperature limits, all may have the same efficiency. What do you mean by thermodynamical equilibrium? A system is said to be in thermodynamical equilibrium if it is in mechanical, thermal, and chemical equilibrium at the same time. What is meant by entropy of a system? A system's change in entropy ds is defined as the amount of heat energy given or taken away from a system divided by its absolute temperature. What is a change in entropy in a reversible process? In a reversible process, the change in entropy ds equal to 0. This means that entropy is a constant in a reversible process. What is the change in entropy in an irreversible process? In an irreversible process, the change in entropy is greater than 0. Therefore, entropy is not a constant. In an irreversible process, entropy increases. How does the entropy of an isolated system change? An isolated system's entropy remains constant or increases depending on whether the changes it undergoes are reversible or irreversible. The law of increase of entropy refers to the tendency of an isolated system to shift towards a high entropy state in an irreversible process. The universe's entropy is always increasing. Why? All the natural processes are irreversible. We know that in an irreversible process, entropy is getting increased. Therefore, the entropy of the universe is always increasing. What is meant by heat death or thermal death? if the temperature difference exists, universal process like conduction and radiation continue, and the universe proceeds in the direction of thermal equilibrium. Thus, the system's entropy increases with the consequent decrease in available energy. The energy which can be converted into mechanical work is called available energy. The energy which cannot be converted into mechanical work is called unavailable energy. Suppose at a particular stage, if all the bodies are at the same temperature, there is no talk about the conversion of energy into mechanical work. That state is called thermal death or heat death. No heat energy may be available to convert it into useful work in a particular state. Such a situation is called heat death or thermal death. Give the Clausius inequality regarding entropy. ds greater than or equal to 0 is Clausius inequality. ds equal to 0 holds good for a reversible process. ds greater than 0 holds good for a irreversible process. What is meant by thermodynamical or Kelvin scale of temperature? The thermodynamical or Kelvin scale of temperature is that scale on which any two temperatures are in the same ratio as the quantities of heat absorbed and rejected by Carnot's reversible engine operating between these two temperature limits. What do you mean by 0 of absolute or thermodynamical scale? The absolute or thermodynamical scale 0 is defined as the temperature of the zinc at which the reversible heat engine going through Carnot's cycle rejects no heat to it. What is meant by a refrigerator? The refrigerator is a heat pump that works in the opposite direction of the Carnot engine. The refrigerator transfers heat energy from zinc to a source, cold body to a hot body. Define the performance coefficient of a refrigerator. Beta equal to T2 divided by T1 minus T2 is a performance coefficient of a refrigerator. Performance coefficient is defined as the ratio of the heat drawn from the cold body to the work done on the machine. What is meant by water equivalent? The amount of water will absorb the same quantity of heat as the substance for the same rise in temperature is called water equivalent. Let the mass of the substance be m, specific heat c, and rise in temperature theta, h equal to mc theta. This is our heat capacity. If the water equivalent is w, h equal to w into 1 into theta. Therefore, w into 1 into theta equal to mc theta, then w equal to m into c. The unit of w is grams. Define calorie. A calorie is the amount of heat energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius.